14.
14. Okay, let's do number 14. You only get to pick a problem if you did the whole thing, okay? Alright, oh, 14 I didn't have the right answer to, so I apologize. No, wait, not 14. It's not 14, 13 I didn't have the right answer to. 13 or 14? You wanted 14, right? You want that one? Okay, let's do 14. Okay, so remember, if this one in particular doesn't show us the, whatchamacallit, it doesn't give us the actual name of the formula, right? But it does have this theta over 2 part. So what you would do is take your chart, because remember I'm going to give you a copy of the chart, and look down your equations to find that. Okay? And you're going to find that under the half angle. And again, that chart with the half angle is only in your notes notebook. Okay? So let's write down the formula first. So make sure we've got the formula part. And then we'll deal with the triangle from there. Okay, so help me out with the half angle formula. What does it say for the formula? Cosine. I heard plus or minus. What else? Square root. Okay, what else? Okay, so you look it up. You know, it's no books right here. Plus or minus? What is it? Plus, and then what trick? Cosine theta divided by 2. Okay. So on this triangle, I only really need the cosine of it, right? Am I able to get the cosine the way the triangle's set up? No, I'm missing the hypotenuse, right? But we know it's a 5, 12, what? 13. And if you didn't have that memorized, use the Pythagorean theorem. Okay? So now I can get the cosine of the triangle. So what is the cosine of that triangle? 12 and 13. Instead of writing 1, what do I want to write instead? Good, and then divided by 2. Again, we're going to do a couple of steps at once. So it's 13 13s plus 12 13s.
25 13s.
Good, and then this thing I'm going to do what with? Reciprocal, good. There's nothing that simplifies. So on the top I've got 25, what do I have on the bottom? 26, square root of 25 is 5 over square root of 26. From there, some of you multiple choice will probably be able to pick out the answer without doing the rationalizing. So, okay. Alright. Marcus, you get to pick, and then Kylo, you're next, okay? So Marcus, which one do you want? 4? Alright. Number 4, use the fundamental identities. It doesn't necessarily mean the basic ones, it really could be all of them. But this one happens to look more Pythagorean than anything else. So we would look up at our Pythagorean identities here. The pink sign. Though the Pythagoreans will be on your sheet, they aren't rearranged like the pink sign is. You're probably still going to want to use the pink sign. Okay? So what can I replace cosecant squared minus 1 with? So tangent squared, and then I'm going to drop down my sine squared. That doesn't look simple enough, right? What can I do with cotangent? Cosine squared over sine squared, and what happens there? The sines cancel. That looks pretty. It's probably as simple as we're going to go, right? All right. Caitlin, you're next. I don't know what you want. 5? Okay. All right. Number 5. I basically need to get the left side to look like the right side, right? What do I want to, what's another name for secant? Remember cosine. And I could take it, you could probably go to tangent from there, but if you feel like you need to see this, you could rewrite it. Sine over cosine equals tangent. So I would expect to see 1 to 2 lines in between. Okay. All right, when you're next, Caitlin, what do you want? 8. All right, so number 8. This is a unit circle problem. Again, you may have your own circles. I'm still going to check them. But there's also the unit circle that's on that page, and it's got all the radians on it for you. Okay? All right. so what x values does, or does it equal, does the gradient equal? Gradient measures are what am I looking at? Okay, I heard pi over 3. What's my other one? You need to look for your x value coordinate. And tell me the two gradient measures. There you go. Okay, now remember whatever's in there, whether it's just an x or if it's a 2x or a 10x or whatever, we set that whatever's inside equal to the gradient measure. Now I've got to move the 2's. How do we do that? Divide by 2 or multiply by reciprocal 1/2. Good. So I really get that x equals pi over 6 and x equals 5 pi over 6. Okay. All right. Bridget, you're next. What do you want? 4. What we did 4 already. 9. All right, so number 9, this is a good question. It might be confusing the way it's asked, but once you see what it is, it really isn't so bad, okay? So it's going to act like a multiple response problem, except that I need the letters listed in order. And you're going to list the letters, no spaces, no commas, okay? I'm going to start with the left side. And you're going to list all the steps, including the first step. So I'm going to start by listing tangent squared x, cosine squared x. What letter choice is that? B. I am going to show you at the end 2 separate ways to do this. I will do it 2 different ways. Okay? Alright, so the next thing I'm going to do is I'm going to default to, hey, I'm going to put it in the sines and cosines. So what's another name for tangent? Good. Notice, I did not go looking at my answer choices and trying to figure it out, did I? I just thought, okay, I know the next logical thing to do is to try to do sines and cosines. So I'm going to do that. Now I'm going to look at my letter choices. What letter choice is that one? G. It's G. And lo and behold, what I thought was true was one of my choices. Okay? All right, what happens now? The cosines cancel, so my next line would just be sine squared x, which is what letter choice? F. All right, now I'm probably looking at where I've got to go. I probably need to look Pythagorean. Go look at the Pythagorean sign. What can I place? Sine squared. Good, and that's letter choice C, which happens to be our end line, right? So what you would type in is B, G, F, C. It has to be in the right order. Did I use all 8 choices? You shouldn't. Okay? Only use the choices that you need. Okay? All right, we're going to do this second way. There's another way that works out with what's there. Okay? The idea of having it all listed there was to give you some confidence that you were actually getting the right steps. Okay? So again, I wouldn't try to match the steps in order. I would try to just write out what I thought and then look at it and see if it's there. Okay? All right, the next thing I'm going to do is I'm going to use a Pythagorean identity on this one. Okay, so what can I replace tangent squared with? No, it's not Pythagorean.
Secant squared.
Good. I'm doing it a different way, right? So secant squared x minus 1 times cosine squared x. What choice is that? H. The second correct answer. Okay. Now what? Instinct would say, hey, let's distribute them, right? Cosine squared x minus cosine squared x. Is that one of our choices?
Yes.
Which one?
D.
That's D. All right. I know that secant and cosine are reciprocals, right? So what can I do with that secant? 1 over cosine of hair cos, in this case, cosine squared. Hold on, you're right. Cosine squared x minus cosine squared x. Now what? Cosine cancel. Is this one here, sorry, without the canceling, is that there? What choice is it? E, right? And then my last one would be that last line. I did the canceling too fast. And then this one would be C. So I can also put B, H, E, B, C. Okay? All right. Use that one. That one is sorry. Alright, so first thing I'm looking at is I'm going to look at that domain that they gave me. They're saying it has to go from 3 pi over 2 to 2 pi, so I have to have a quadrant 4 answer. Okay? Next is telling me about tangent, and then if I do triangles, I have to think about it in Sohcahtoa world, not in identity world. So what is tangent in Sohcahtoa world? Alright, so I'm going to put the opposite 3 and the adjacent 4. Which one gets the negative? 3 because it's going down, right? It's going in the negative direction. What's my hypotenuse? 5. Alright, so I've got my triangle set up. I know that has to be the reference angle. Now I'm going to actually look at what I got to solve. It's very explicit. It says use double angle. So I look at my sheet and I find double angle. I need to find sine of 2u. So what does the formula start with? 2 sine theta, cosine theta. What's the sine of that triangle? 3 over 5. I wrote the fourth typo. Alright, and what's the cosine of it? Good. I don't know why, but I like denominator or put my denominators first. It's 5 times 5. And then 2 times negative 3 times 4 is good. And there's not much else I can do with it, right? Alright. Mackenzie, you're next. Okay, which one do you want? 15. Alright, again, we're going to be very, very explicit. They tell us to go product to sum. So I'm going to look for that heading on my piece, on my reference sheet, right? So product to sum starts with what number? 1/2. Okay, you're going to read me the formula. I want the one that says cosine times sine. What trig does it start with? Sine, and in the parentheses, what operation? Plus outside the parentheses operation. And then the trig, sine again, and inside the parentheses operation. Once you've got that, the rest of it's really easy. Okay? I gotta take my angle measures and drop them in. So 3 theta, 2 theta. 3 theta, 2 theta. Okay, what's 2 theta plus 3 theta? 5 theta. 5 theta. Let's drop this in. Alright, 3 theta minus 2 theta. 1 theta, that's it. Don't try to combine the signs together. They're not like terms. Okay? Alright, Javier, you're next. Mackenzie, which one do you want? Number 6. Alright. We have to verify the identity. Typically, we work with a side that is more complicated. So which side is more complicated, the left or the right? The left. Okay. So with the left side, I'm noticing I see 2 of those. What should I do? Take one out. What's that called? Is it a name? Okay, I heard factoring. It's actually specifically what kind of factoring? Starts with a G. Okay. It's the greatest common factor, right? So I'm going to take out a secant squared, what's left in the first term. Tangent squared x, and then I'm going to take out a secant, what's left? 1. I know I got to get the secant to the fourth. That looks awfully pink sign to me, right? So look at your pink sign, and what can I replace that with? Secant squared, good. Secant squared times secant is? Secant, did I get what I wanted? But of course your grade is going to come from the 2 lines in between. Okay? Alright, let's see. The next person who gets to pick, Nicholas, you're going to pick next. Javier, which one do you want? 11? Alright. This is probably the worst problem on the whole test. Okay? There was the one that was there earlier in the day was even worse than this one. Okay? In all of them, you end up having to do the power reducing twice. Okay? There's no way around it. I don't know what we're going to do on the test. A really good replacement for the cosine on the test, though, is what? Sine. And they work almost identical, right? You have between now and Monday, if you practice this one 5 or 6 times, you'll get it. There's a lot of algebra we only have squared things, so we're going to get cosine squared squared. All right, help me out with the power reducing formula. What am I going to put in?
Plus cosine over 2.
Good. Okay. Let's deal with the denominator first. What's 2 squared? 4. And it would be great if I didn't have to mess with the denominator anymore, right? So I'm going to pull it out as a 1/4. What does the squared mean to do with the numerator? We're going to write it how many times? 2. Write it twice. Normally, I would probably just do that step. Yeah, I lost a 2 at the end. Plus sign. All right. I'm going to show every single little step because I want to make sure we've got this for the test. But there are some things we can probably skip here and there. Okay. All right. The plus sign means I have to do all of FOIL. This is the thing where the middle doubles. Okay. If the signs are opposite, that's where I only have to do first and last. Okay. So it's 1 times what? 1. Good. 1 times cosine 2x. How many do I have? 2 of them. The middle doubles. All right. Cosine 2x times cosine 2x is
Cosine squared.
cosine squared. The square goes on the trig. 2x. All right. Am I in first power of cosine? No, one of them's in second power, so I still have to do another power reducing right here. That's part of what makes this pain. Okay, power reducing part really isn't too bad. All right, I got to get a power reducing in there for cosine again, so we get 1 plus what? 2x over 2. What gets substituted in those parentheses? That 2x. There's 2 x's all over the place. Okay? So what really I get cosine of what? 4x. Okay. Now at this point, you've got it reduced, but this is not likely what the multiple choice answer is going to look like, even with a 4x in there. Okay, so I'm going to keep going and showing you the algebra to get you there. Okay? This part's not pretty. Right? This is typically when we go on further in math. The calculus part is really, really easy. Calculus for it. It's the algebra piece that's the killer. Most of them get the calculus piece fine. It's the algebra that usually the algebra stuff. Okay. All right. I'm seeing that this and this are like terms. All I did was split the fraction up. Okay. So what can I make the 1 instead of 1? 2 over 2. Okay. So 2 over 2 plus 1 over 2 is 3 over 2 plus 2 cosine 2x plus 1/2 cosine 4x. Again, another perfectly good answer. Right? The problem is, for some reason, multiple choice test writers will not just leave it like that. Okay? You see how we have these 2's in the denominator? What they were going to do is they're going to factor out a 1/2. Okay, so let me show you how that happens. We're going to make this into halves. So 2 over 1 is how many halves? 4, right? We have to multiply top and bottom by 4. Cosine 2x plus 1/2 cosine 4x. All right, now do you see the 2's in all the denominators? Yeah, so we're going to go ahead and pull that out. Greatest common factor. And then inside here, we get rid of all the 2's in the denominators because we took it out. So 3 plus 4 cosine 2x plus cosine 4x. The only thing left to do is multiply the 1/4 through 1/2 to get 1/8. So if you ever see something really weird, a really weird coefficient, you couldn't figure out what happened, likely there was, especially a fractional one, likely there's some weird denominator they factored out. Okay? Like I said, we had the answer back here in that line, didn't we? With another 5 lines just to try to get it to multiple choice like answer. Alright. Javier, that one was yours, right?
Yeah.
Okay, Nicholas, you get to pick red, you're next. Which one? 16. Is reading number 16? Alright. If they're very explicit, they're cosine, and what operation? Minus over, then what do I do? Plug in what? 4x and 10, those angles, right? Those are the angles. Okay, now we're doing combining like terms. So let's see what's 4x plus 10x. 14x over 2, and then 4x minus 10x is over 2, good. Okay, 14x over 2 is 7x, and negative 6x over 2 is, you like that negative green sign? This is where your green sign comes in, or on your sheet, they say even odd. Okay? But you can, the signs will be there, so you can use the sign. Okay, so for cosine, does the negative go out front, or does it disappear? It disappears. So 2 sine 7x cosine 3x. Okay? Alright, Anthony, you're next. Greg, what do you want? 12. Alright. There are actually 2 ways to do this one, but we're not going to count on the one where you just transfer it over with the orange sign. It happens to be that I picked pi over 2. It might not be pi over 2 on the test. Okay? It could be pi over 3, and then the orange sign doesn't work. Okay, does that make sense? Because the answer should be cosine. Right? So we're going to do this one with the sum and difference formula. This was the sine, cosine, cosine, sine, cosine, cosine, sine, sine stuff. Right? You know that because there's one sign and an addition or subtraction with two terms in there. Right? The other one usually will say sum to product. Right? So, what's my sign pattern? Good. All right. And again, that one it'll be on the paper, but if you know it, even better, right? All right. What operational symbol do I keep it or change it? Keep it, and then we've got pi over 2 and x in order. All right. The sign we're doing unit circle now, right? What's the sign of pi over 2? One times the cosine of x. What's the cosine of pi over 2? 0 times sine x. So what happens with this back piece? So what we just did was we proved the orange sign. It was a little proof, right? We proved it with the sum and difference identity. Okay? Alright. That one was gray, right? Okay, so Anthony, you can take this into your lap. You're next, okay?
Have we done 2?
Take your lap. Let's do 2. Alright. I don't think I've done this one all day. You guys got it's a good bit, right? Because it's not any of the other good ones. Alright. So, it says we're supposed to factor. What kind of factoring do we have there? Difference of squares. Good. Alright, so what is the square root of secant to the 4th? Secant squared. Okay, what is the square root of tangent to the 4th? Tangent squared, and for difference of squares, we make 1a and 1a. Okay. Here is now where we're going to try to use some of our identities. Okay. I would look up at my sign. Go look at the pink sign because it looks kind of Pythagorean. Is there one of these 2 things that we can replace with something on the pink sign? Which one? Okay, so that can get replaced with what? 1, and then this guy just stays the way he is, right? I know there was another one that had something, but I don't think it matches. So 1 times that is just itself, right? Secant squared x plus tangent squared x. All right. we get sine over cosine, 1 over cosine.
Yeah,
It's not, it's going to just keep going in loops. Okay? All right, so which one do you want? Number 7. Okay. We've got to solve for number 7. I want to first of all get the 2 to the other side. How do we do that? Got it. Good. Now, the solving one, we know we've got to go unit circle. Is secant on the unit circle? But who's related to secant that is on the unit circle? Cosine. What's their relationship? Reciprocal. So I'm going to get what for cosine? Good. Is cosine the x value or the y value? X value. Okay. So I want you to look for everywhere in radian where the x value is 1/2. Okay. All right. And then I said that the class gets, should be only 2 or 3 left, right? Number 1, 3. You guys get 2 more. 1, 3, or 10 is the class. What do you guys want? Number 1? Okay. Number 1. All right, so we have to evaluate. This instruction says all 6. I left it that way, even though on the test it will probably only ask you to do 1. Okay? But you don't know which one, this way we practice all of them. Okay? All right, first thing I'm going to look at is which quadrant I'm located in, because I might need that information somewhere. Is cosine positive or negative? So which quadrants does that qualify? 1 and 4, okay, and then cotangent says he's negative, or which quadrant is cotangent negative? 4, so all my answers have to be quadrant 4 answers. Good news is I get 2 of them for free, right? What do I get for free? Secant and tangent, okay, good. What do I have to do to get those? Flip into the reciprocal. So 2 over square root of 2, which I'm supposed to rationalize. So 2 squared root of 2 over 2, and I cancel and I get square root of 2. Right? What's the reciprocal of -1? -1, right? Okay, what is missing? Sine and cosecant. Now, if you remember from chapter 4 how to set up the triangles and do the triangles, you can do that. In this specific case, if you recognize this is a unit circle thing, you can use your unit circle. Okay? I'm going to show you how we did it in this chapter. Okay? We're going to use a Pythagorean identity. I can pick either sine squared plus cosine squared equals 1, or the one with the cotangent, the cosecant. I'm going to go with that one because the -1 is a lot easier to deal with than this radical one. Okay? So I'm going to go with 1 plus cotangent squared theta equals cosecant squared theta. All right, what's your cotangent? -1, we're going to square it, and then we don't know cosecant, that's what we're going to try to find. So what is -1 squared? 1 plus 1 is 2. How do I undo the squared? What are we supposed to put in front? Okay, here's where the quadrant comes in, right? In quadrant 4, is cosecant supposed to be positive or negative? Negative. So it's negative cosecant squared. Or negative square root 2 is cosecant. What do I get from cosecant? Sine, and we have to flip the reciprocal, so 1 over square root of 2. We have negative square root of 2 over 2. Alright, it was 3 and 10, right? So which one do you guys want to see as a class? 10? Okay. 10 is a very, very freaky kind of problem. Okay? This is another way for me to easily grade a verifying identity, and you at least have to give me one of the steps. Okay? So, if you kind of start, you got to follow what it's trying to do. If you gave me tangent back, you're not going to get to this line, right? So they said they turned tangent into sine over cosine. What would be the next thing we would want to do? And then you write down what's left. Type or whatever it is. Cosine squared x sine squared x. Then check it. What's cosine squared plus sine squared? So we got back to what they got to. Okay? Alright, the last one will just have to leave this. Okay? Alright, that's it. I did post in Haiku the page numbers of the notes that are due by Monday. We decided 159 and 227. That's a good chunk. Make sure you have 2 questions, essential questions, summary, and your table of contents gets updated. Okay? Trust me, you're going to want that table of contents when you're at home doing calculus and you forgot how to factor. Okay? Or all of a sudden, second semester, we pull the logs out of calculus, we haven't done those in here. Okay? Alright. I'm done talking. If you want stamps, you can get stamps. Tomorrow there'll be some kind of an extra credit opportunity and time to work.